This is lesson 11.7 on areas and volumes of similar solids. In a previous chapter, we talked about similar polygons. And so if two polygons are similar, that means that they have a common scale factor. So the ratios of all the corresponding sides is the same. Scale factor is written as a ratio. So if the scale factor is a to b, we also discussed that the areas of those similar figures would be a squared to b squared. This also happens for three-dimensional figures. So if the three-dimensional figures are similar to each other, then that means that their corresponding surface area and lateral areas will be in the ratio of the square of the scale factor, and their volume ratio will be the cube of the scale factor. So all linear dimensions, the length, width, and height, has to have the scale factor in order for that 3D object to be similar to another one. So here's an example of two rectangular solids. The first question, are they similar? Okay, so we're going to do just like we did before and check if the sides are proportional. So I'm doing a scale factor type of calculation. I want to know if 2 to 4 to 8, I'm going small to medium to large, and in the same order, same position on the two figures, 3 to 6 to 12. Well, on the left side, we can divide it into 2, which will become 1 to 2 to 4. And on the right side, divide it into 3, 1 to 2 to 4. And since they are equal to each other, that means that yes, they are similar. All three dimensions are proportional. Okay, ratio of their lateral areas and surface areas. Okay, so the scale factor is 2 to 3. So since the area is the square of the scale factor, we'll do 2/3 squared and get 4 to 9. So the area ratio is 4 to 9. And the volume ratio is the cube of the scale factor. So we'll do 2 to 3 cubed, which is 8 to 27. I'm out of room. Let me try that again. It's 8 to 27. Okay, so that's the cube of the scale factor, 8 to 27. In this problem, we have two pyramids that are similar, and it says that the volumes are in the is at 216 cubic inches to 125 cubic inches. So we're going to first find the scale factor because we want to know the ratio of their surface areas, but what you need to do is take their cubic volumes and reduce it back into, or revert it back into, I don't know how you want to say that, take it back into the scale factor. So the way we're going to do that is we're going to take the cube root of the ratio. So if it was in a 216 to 125 ratio of volumes, then that means the scale factor will be the cube root of 216, which is 6, and the cube root of 125, which is 5. It'll be in a 6 to 5 ratio. So the surface area ratio should be the square of the scale factor. So that should be a 6 to 5 squared ratio, or 6 squared to 5 squared. So 36 to 25 is their surface area ratio. 36 to 25. Now, they're telling us that the surface area of the larger pyramid is 250 square inches. So if the surface area ratio is 36 to 25, and the larger pyramid has an area of 250, then we're going to set up a proportion to find the smaller surface area. 250 times 25 is 6,250. is equal to 36x. And when we divide both sides by 36, this one's not going to divide evenly. We'll go ahead and round it. It's approximately 173.6. And that's a surface area, so that will be in inches squared. Okay, so again, to recap, if the scale factor is A to B, then the area ratios will be A squared to B squared, and the volume ratios will be A cubed to B cubed. So if you're trying to go backwards from area back to scale factor, use square root. And if you're going to go from volume back to the scale factor, you will cube root. That's the end of this lesson.